Here we have a program that scans a grid of bumps, and we are interested in measuring the height and x and y deviations of each bump. The height of the bump is measured as the maximum height relative to the immediate substrate around it, which helps eliminate any warpage of the sample that would affect the measurement. In order to determine the x and y deviations, we can first import the nominal positions, such as from a pin map or drawing, easily as a CSV file. This will tell the system where a feature, in this case a bump, should be located. The program will use built-in feature finding in order to isolate each bump and then calculate the measured position. In our automation software AScan, we are provided with a quick overview of the final result for the measurement. We can click through each bump for a closer look. Here, the red measurement cursor shows where the system has detected there to be a bump, and the green reference cursor shows where the bump is expected to be. From this, a calculation is made from the difference between the actual physical location and the expected nominal position, resulting in the deviations in x and y along with the absolute deviation. We also have built-in SPC charts in order to track the measurements. In this case, any absolute deviation above 3 microns shows a warning, and anything above 4 microns is flagged as bad. In this example, we can see the absolute deviation is only 0.16 microns, and visually, the center of the red and green cursors are very close without much offset. As we scroll through, we can see the data for each bump. However, for this bump, we can see the deviation is 4.56 microns, and when we click on it, it is clear that there is in fact a large offset. We can export the result automatically as a 3D surface image that shows the entire scan area and each bump. A color height ramp is added so that you can clearly identify which bumps are higher or lower than others. We can also import the results as a heat map, in this case showing the distribution of the absolute deviation measurements across the sample. All of these and many other measurements can be easily performed and fully automated with our series of benchtop or standalone metrology systems. For HVM high-throughput use cases, we offer a dual system metrology cell that combines a central wafer handler with 2 independent metrology stations. Thank you for taking the time to review this short demonstration. If you are interested in more details or would like to discuss your metrology requirements, please feel free to reach out to us at info@cybertechnologies.com.